Hello guys and welcome back to my channel Interview with Bunny, and we are back with another video on system designing playlist, and the topic or the application that we will be designing today is none other than designing the leaderboard. So before solving this problem, let's first understand that what this problem statement actually means. So designing a leaderboard actually means that you need to fetch the top K trending list or the top K value from the billions of lists that we have in our database. So for example, there is a gaming platform, those who are organizing a competition on a global level, and at a particular moment of the time, we have to give a system to them such that they can retrieve the top 50 or the top 100 candidates having the maximum score. Similarly, the same concept can be applied for the trending topics or the trending list of the videos or songs that are played on the Spotify. So with the help of the same leaderboard concept, you can also solve the similar problem. So with this understanding that what we are solving over here, let's start with the first step of our designing, and that is the gathering of the functional requirement. So the functional requirement of this problem statement is very straightforward and simple, because here you have to solve only one major problem statement, that is to find out the top K trending list of the songs, video, anything based on some dimension, maybe based on some views, like, or anything it can be. So that is the main functional requirement that we have to solve over here, and the solution should be highly optimal. So without wasting much time, let's see what can be the other functional requirement that we have to gather over here from your interviewer, and what are the list of functional requirement that we will be solving here. So the first and the most important requirement that we will be listing here is the user or the client should be able to query our database or query our service to fetch the top K list of songs, videos, or scores from our backend. So that will be our first primary requirement. Number two, we have to give our user a system by which they can also ingest the data into our systems, because without the data we cannot give the provision for the query. So we have to solve both the requirement, that is the insertion of the data. It can be the score of the player, it can be the total number of views of the video whatsoever, and also we have to give the functionality to query our database. Clear? Now the third requirement is we have to give the functionality to query our database, but with some filter criteria. Means it can be the top K trending list based on some time frame. So for example, I as a user want to see all the top 5 or the top 100 videos from the YouTube for the last 90 days. So here we have to give the provision of giving a time frame in the query search. So that will be our third requirement. And the last and the fourth requirement should be we have to give the provision for the user to get the real-time update of the trending list. So this is only applicable in case of the leaderboards. So for example, a gaming platform is hosting an event, so obviously they need to see all the leaderboards in near real time. So here we have to give the provision to get all the trending lists in the near real time, but this is only applicable for the leaderboard events where you have to display the scores and all these things, because this real-time update doesn't matter for any trending songs or trending movies. So with this understanding that this will be the four primary functional requirement that we will be solving over here, let me first write down all these things so that it will be very easy for you to understand. So these are all the functional requirements that we will be solving over here. That is, user should have the ability to insert, update, or delete the data. Number two, user should have the ability to query our top K list from our backend. Number three, we have to give the provision of selecting a time period. It can be an hour, day, month, or it can be an all-time list. And last but not the least, user should get the real-time update of the score or the leaderboard. So these are all the four functional requirements that we will be solving over here. So since we are done with our first step, that is the gathering of the functional requirement, let's go to our next part, and that is the gathering of the non-functional requirement. And as you know, the non-functional requirement tells that what is the size of the system, how should be the latency, and all those things. And believe me, this non-functional requirement is critical over here, because based on those numbers only, we will determine that how we should design this system. So let's see what will be the non-functional requirement that we will be solving here. So the first non-functional requirement that we have to get an estimation, and that is the scale of the system. And believe me, for this particular problem, problem, the scale of the system is very much crucial, because for this problem, the entire designing or how we will be designing the system depends on the amount of the load or the scale that you are targeting to. In this video, for the first time, I will give you the 4 solution of how to solve this problem based on the scale of the system. Means if it is a nominal scale, or it is a mid-level scale, or for a high volume of the data. So based on the scale or the volume of the data, I will be giving you the 4 solution of solving this problem, so that in case your interviewer asks you to modify your design to support a huge volume of data, you can easily do it during your technical interview. So let's first see what is the volume or the scale of the system that we are targeting over here. So the scale or the volume of the data that we will be targeting over here will be quite huge, because if you are considering that you are designing a top trending list for YouTube, so obviously here the volume of the data or the total number of requests that we will be receiving in the backend will be quite huge. So let's see what can be the scale over here. So the total number of requests that we are targeting over here is around 1 million requests per second. So just to give you an idea, this is not the request that we are getting to find the top K trending item. Rather, it is the insertion that is happening in our backend. So obviously, once there is a like on a particular video, all those events will come into our service for insertion. So this is the volume of the requests that our system should handle. So this is the estimation of that only. Clear? Now the next thing is like the total number of data that we have to save in our backend. So for example, we are creating a backend for the Spotify or the YouTube. So obviously there will be a millions or billions of videos or song in the backend. So here you can easily understand that the volume of the data is very high. So I will write it as a billions of songs, video or players. So based on the problem statement that you are getting during your interview, change it accordingly. So for example, you are creating a backend system for the YouTube. At that time, it will be billions of videos. On the other hand, if it is a backend system for Spotify, it will be the billions of songs. So based on the use case, just list it accordingly. Clear? Now comes the next thing, and that is the cap theorem. And as you know, the cap theorem tells that whenever you are creating a distributed system, you either have to compromise between the availability or the consistency of a data on a particular module. Means a particular module cannot be highly consistent or highly available at the same time. We have to compromise between the two. And if you understand this platform clearly, our platform should be highly available rather than consistent, because of the fact at a particular moment of time, whenever a third party or the client is hitting our system, we should return some list of trending topics to the front end. It should not happen that a client is requesting data from our backend and we are giving a 404 or service unavailability. So at every moment of the time, our system should be highly available. And here it is quite acceptable that our system should be eventual consistent. Means it is not required that at a 0th second, if a particular video is moving from the position 2 to position 1, we have to show it to our user. We can obviously go with an eventual consistency over there. I hope this is clear that why we are targeting high availability rather than high consistency. Now the next important non-functional requirement that we have to gather from our interviewer is the latency of the system. And here, just like the scale of the system, latency is also quite crucial, because our system should be highly optimized to fetch the top K trending list of items in the near real time. So here, to fetch the result of the top K trending topics, here we will be giving a latency of 100 milliseconds, means it will be a near real time. And to insert or update our data into a system, it can be a 500 milliseconds. So let me quantify all this point over here and write it so that it will be very easy for you to understand. So here you can see the latency to fetch the K trending topic should be 100 milliseconds, and to update a data or to delete a data from our list or from our backend can be a 500 milliseconds. And obviously, whenever you are deleting some record from our system, there can be a change in the position of the rank of the songs or the video. And that is why, since here we are taking 500 milliseconds, so here it will be not a near real-time update, rather a soft real-time update. Means it will be taking a bit of time to update it in our database and then give the next list of trending topic to the front end. So I hope this is clear. And the last but not the least, another important point that you have to discuss with your interviewer, and that is quite crucial, that is here we will be designing our system with the assumption that we will be giving the accurate result, not a probabilistic result. Means we are not giving an assumption or probability that a topic can be at the top or it can be at the second. Here we are computing all the set of data, and based on that we are giving the exact data point that this is the top 10 trending topic that we have for our videos or for our songs. So here just make it clear with your interviewer that what he is asking for, whether he is asking for to design a probabilistic top K trending topic or he is asking for an accurate trending topic. So based on that your design will change completely, and that is why it is a crucial point to mention it at the very beginning. But do not worry, though we will be solving this problem with the assumption that we will be giving the accurate result at any point of the time, but I will also give you a suggestion at the very end of the video that how you can enhance our designing so that you can also return the probabilistic trending topic from our designing. So let me list down that point also. So here you can see these are all the functional and the non-functional requirements that we will try to solve over here. And here you can easily understand that both the functional and the non-functional requirement is very important, because based on this requirement our design will change accordingly. Now since we are done with the first step of our designing, and that is gathering of the functional and the non-functional requirement, let's go to the next step of our designing, and that is identification of the core entity. And here if you look carefully in our system, there are only a couple of core entities that we can point out over here. Number one is the score, the view or the like, means the attribute based on which we will be trending a topic. Number two, the actual entity, means it can be a player score, it can be a video view, or it can be a song likes or number of time it got played. So that will be our second core entity. And the next core entity will be the time frame that we are giving the user to query our database. So let me list down all this point over here. So these are all the core entities that we can identify as of now. So it can happen that there will be few more entities that we can identify while designing the system, but based on the requirement that we have gathered as of now, these are the core entities that we can find out right now. So since we are done with the two steps, that is gathering of the functional requirement and the identification of the core entity, let's go into the next step of our designing, that is the third step, and that is the API designing. So let's see what are the public REST endpoint that we have to expose for our client so that all the requirements gets fulfilled. So let's move to our third step, and that is the API designing. And as you know, designing the REST API is quite simple if you have gathered the functional requirement correctly, because in most of the time it is just a one-to-one mapping or one-to-n mapping between the functional requirement and the API that we need to fulfill that requirement. So let me first write down all the API endpoints that we need here, and after that I will explain you that how each and every endpoint will work and how it will serve the purpose. So these are all the three most important endpoints that we need to solve all our functional requirements. So let's go one by one. So here the first one is a post API to insert the data into our system. So here you can see this is the endpoint to insert the data. So here I have mentioned it with the score for the leaderboard. It can be a view for the video, or it can be a like for the song. So based on your use case, you name it accordingly. And as you know, since here we are inserting the data, so it is a post call. Clear? Now the next endpoint is we have to give the provision to the client to fetch the top K trending topics from our backend. And for that, what we are doing here, we are giving the provision to fetch a leaderboard. And obviously a leaderboard should have an ID. So this is the ID of the leaderboard that we will be sending in the URL. And after that, we are giving the provision to select the time frame. So here you can see here we are giving the window size, means it is a 24-hour, it can be a month, then it will be a 30 days. So based on that, we have to send the parameter accordingly. And after that, we are also giving the provision to select the region and the value of the K, that is the trending topic that we will be returning as our response. So here if you look carefully, this region is actually very much important, because the trending list of the songs in India differ from that in the US. So the region is very much needed for this designing. Along with that, here we have to keep an upper bound of this value of the key. So this key cannot be anything. It should be 100 or 10,000 record for a particular request. So it should not happen that at a particular instance, a client want to see billions of trending event from our backend. So the value of the key should be well defined in our system requirement document or whenever we are defining our system. So here we can assume that the value of the key will range from 1 to 10,000. So that is the upper limit of the key that we are defining over here. So why it is important, you will get to know when we will be designing our system. And obviously if someone is giving a value of k as 10,000, it is not possible to return all the 10,000 record at a particular instance. So what we will be doing, we will be giving in the form of the pagination. Clear? Now the next important thing is this request is supported by both the WebSocket connection as well as by the REST API. So what it means that, so for example, you are creating a trending list of topic for the YouTube. At that time, it should not be a WebSocket connection. It will be simply a GET call. But if you are creating a leaderboard where we need the data of real-time update of the top K trending topic, at that time, it will be a WebSocket connection to get the near real-time data. Clear? And the last endpoint that we have defined over here is only required for the gaming platform, means for a particular instance we are trying to look up for the rank. So here what it means that here we are sending a user ID and the month for which we are interested to, and the user or the gamer want to see that what was his rank on this leaderboard on this month of the year. And here we have to also define one more thing, and that is the value of the key. And what the value of key stand over here, this tells that who are the players that are around me. So for example, at a particular month on January, I want to see my rank on a particular dashboard. So what I will see, what I will send, I will here send my user ID, and in the window I will send it as January. And once I give the value of K as 5, it will return my rank on the month of the January as well as all the 5 players who are around me. So for example, I am at the 3rd position. It will give the 2 from the above and 2 from the below. I hope this is clear that what this API endpoint actually stand for and why I have defined it over here, though it was not the part of the functional requirement. That is because your interviewer will definitely ask this question as your follow-up question if you are trying to design a leaderboard. So here if you look carefully, we have found out all the functional requirement, non-functional requirement, and we have also pointed out what are the core entities and the API endpoints that we need to fulfill all the functional requirements. Now since we are done with all the 3 major steps of our designing, let's go to the next step of our designing, and that is the high level designing of this entire architecture, where we will see all the major components that are needed to fulfill all this functional requirement. So without wasting much time, let's go to the next step of our designing, and that is the high level designing of this application. And here if you look carefully, the high level designing of this architecture is very simple, because here we just have to solve few of the points from our functional requirement. That is, we have to give the provision to insert or update the data. We have to give the provision to fetch data from our backend. So these are the 2 very important functional requirements that we have to solve here. So let's see what are the components that we need to fulfill all these things. So the first thing that we need is a client who will be actually using our application. So this will be our list of clients or the user. Now the next thing is, obviously since here you can see the scale of the system is quite huge, so it is quite obvious that we will be going with a microservice architecture. And whenever we are going with a microservice architecture, so what we have to do, we have to introduce our API gateway and a load balancer to distribute all our traffic evenly in our backend services. So this will be our first component of our designing, that is the API gateway and the load balancer. And as you know, the roles and the responsibility of the API gateway and the load balancer is authentication and authorization, routing, and the rate limiting. And the algorithm that we will be using over here for distributing the traffic evenly across all our server is nothing but the round robin approach. So I hope this is clear. This is quite straightforward and simple. So what is happening, all the request is coming into our API gateway and our load balancer. And here the first requirement that we have to solve is we have to give the provision to the user to insert data into our backend. And to insert our data into our backend, I need a backend server to serve all the requests. So here what I will do, I will create a service over here and I will name it as a score service. So I hope this is clear that whenever there is a new view on a particular video or there is a new score update for a particular user, the request will come into our API gateway, and from there, based on our API endpoint, our API gateway will route the traffic into a score service. And what this score service will do, obviously it have to persist that data so that we can calculate the top K record from that. So for that to persist that data in our backend, we need a database. And here what I will do, I will create a persistent storage and I will name it as the score DB. I hope this is clear that how the flow of inserting the data in our backend is happening. This is quite simple and straightforward. Now the next functional requirement that we will be solving over here is give the user the provision to fetch the top K trending list. And obviously for that also we have to create a separate service to calculate all those logic. And I will name it as the ranking service. And the responsibility of this ranking service will be to look up into this code DB and to find out what are the trending topic or the top scorer of a particular leaderboard, and based on that it will simply return it into the front end. So this is actually the basic flow that you have to fulfill in the high level designing. So here if you look carefully, we have actually solved the high level designing of our architecture. That is, here you can see we have fulfilled all the functional requirements that we have gathered. That is the insertion of the data into our backend as well as fetching the trending list from the backend using our ranking service. I hope this is clear that how this entire system will work and how the data will flow accordingly. But the things are not at all simple as it looks like, because it's quite clear that here you can see that the scale of insertion of the data is 1 million requests per second, and it is obviously not possible for a single server to insert that volume of the data in our backend. Similarly, with that volume of data, it is not possible for this ranking service to fetch the top K trending list in near real time. So let's see in our next part or next step of our designing how we will solve all those non-functional requirements that we have targeted over here and how we should optimize our service to fulfill all our functional as well as the non-functional requirement. So let's go to the next and the last step of our designing, and that is the deep dive or the low-level designing of our system. Before proceeding further, I just wanted to notify that I have created a very simple website over here so that you get all the contents that I upload on the YouTube on a single platform. So here you can see there are lots of content on the system designing, on the low level system designing. Similarly, here we have the complete graph playlist where we have already 15 to 16 video over here, as well as all the latest contents that I'm uploading on the YouTube. I will keep on updating all those things in this website. This is a free website that is hosted also in a free domain. So do not forget to bookmark this website so that it will be helpful for you to find out all the relevant contents regarding your upcoming interview. So let's start with the deep dive or the low-level designing of this system, where we will see in detail that how the score service and the ranking service will work over here and how we can get the top K trending item from thousands and thousands of records in our database. So let's start with the deep dive designing. But before going into the deep dive, I want to tell you this problem statement is actually pretty easy. If you get this question during your algorithm and data structure round, and yes, it is possible that you get the same exact question, because if you see in the lead code, we also have the similar problem. That is the top K frequent elements. That is the lead code 347 number problem. So what this problem statement tells that you are given array of numbers and you have to return the most frequent number. So what does this frequent mean? So this frequent means the total number of time the number appeared in your array. So here if you see, for this number, 1 appeared 3 times, 2 appeared 2 times, and 3 appears only 1 time. And here the value of the K is 2. So obviously if we sort the frequency of this number in the descending manner, then obviously we will be returning 2 integers, that is number 1 and number 2. So this problem statement is also on the same logic, that is the top K trending item. I hope this is clear. And if you just see the solution of this problem, you will see that what we are doing here, we are using a priority queue that is nothing but a heap data structure, or here we can use a tree map to store all the frequency of the number. And then what we will do, we will sort the number based on the frequency, and thereafter we will get the top k element from there. So that is actually the way to solve this problem. So with this concept in mind, that how we will be solving this problem, let's see how we can replicate the same thing in our system design. So what I will do, I will simply copy this entire high level into a low level section. And let's start with enhancing one part at a time. And believe me, for the first time in this problem statement, I will give you 3 ways of solving this problem. Because as I've already told you, this problem statement is very easy if you are handling it on a DSA round. But if it is a system designing round, there will be a multiple follow-up question on each and every approach you give it to the interviewer. So be prepared with all the approaches that you are proposing and also the pros and cons of each of the design. So let's start with our first way of solving this problem. So the first thing that we will do, that is a very basic and the straightforward solution. That is, we will first see how to scale our score service. And what is this score service? This is nothing but an ingestion service by which all the views, scores and all the metadata of a particular entity or the attribute will get ingested into our database. So let's see how we can make this solution scalable and how we can enhance this solution. So what we will do here, if you look carefully, the scale of our system is quite huge. That is, here we are dealing with 1 million requests per second. Means whenever a video is getting opened by thousands and thousands of users across the globe, or maybe billions of users, then all the requests are coming into our backend. And to ingest that huge amount of data, what we need, here we need a server. But obviously, it is not possible for a single server to handle all this data and ingest it in our backend. So what we need, here we need a buffer or a temporary storage unit where we can simply keep all the data that are coming from the user. And once we get all the data from the user, then we will slowly ingest it into our backend. So what we will do, here we will introduce a Kafka broker or a streaming platform. So here what I will do, I will introduce a Kafka broker over here. And the responsibility of the Kafka broker will be whatever the data that is coming from the user, that is all the likes, views, score, whatever, it will first store it in its buffer. And from there, once it is in a particular topic of the Kafka, what we have to do, here we have to write a consumer service. And this consumer service will be mainly responsible to ingest all the data from the Kafka broker into our score database. I hope this is clear. So here I will mention one more service, that is the DB consumer service. Clear? So here what is happening, this DB consumer service is getting the data from the Kafka using the Kafka Connect, and once the data is there in the consumer service, it will simply store it in the score database. Now what type of database this score DB will be, we will discuss it a bit later. Now let's go into the second service, and that is the ranking service. So here we are done with our first service, that is the score service. And here, as you know, this will be replicated into multiple pods and multiple nodes so that it can handle all the requests from the server. That is quite implicit. Now what we will do, we will try to enhance the ranking service by which we will get the top k element from this huge database. And this is actually the trickiest part of this entire designing, that how we will optimize it. So let's go with the first solution or the first way of solving this problem. So as I was discussing a bit earlier, how we can solve this problem, that is with the help of a priority queue or a heap in the memory. So here also we will implement the same thing. That is, here if you see in our lead code, here we have used a priority queue, that is nothing but a heap in the memory. And as you know, the property of the heap is it can sort the element by itself with the help of any attribute you want. So it can be sorted by the score, it can be sorted by the view, howsoever you configure, it will be like that. And once the user is asking for the top k, means we have to pop out the top k element from that heap and we have to give it to the front end. But the actual concept of the heap can be applied on the data structure. But in case of the system designing, we have to find out an alternative technology or an alternative component by which we can get the same functionality by default. And the component by which we can implement the same structure like the heap is nothing but a Redis Sorted Set. I hope this is clear that what we are trying to implement. So here we are doing The same thing, that is, we are creating a heap in our memory by which we will get the top K trending topics from this Redis. Now the question is how the data will go into this Redis sorted set to create the heap in the memory. So here what will happen when the data is getting ingested into our backend, that is with the help of this Kafka broker, there we have to write one more consumer service just like the DB consumer. So here what we will do, here from this Kafka, we will be having one more consumer service that we will call it as a Redis consumer service. So here I will introduce one more component that is as a Redis consumer. And what this Redis consumer will do, it will simply get the data from this Kafka and it will put it into our Redis set. So here the data which we are getting it into the Kafka is going into two directions. One, it is getting persisted in the database, as well as it is going in our Redis sorted set so that we can get the top K trending item from the backend. Now the next question is how this ranking service will get the trending data from this Redis set. So here what will happen, we will not hit the sport database directly. Rather what we will do, we will hit this Redis sorted set to get all the trending topic from the memory. Clear? So what is happening during the ingestion only, all the data is going into our backend, as well as we are having our Redis consumer service who is ingesting into our Redis sorted set or the Z set. And here, since the data is already there, what we are doing with the help of this ranking service, when the user wants a K trending topic, we are simply getting the data from this set and we are showing it to the user. And this is quite a feasible solution to solve this entire problem. But there is a small problem with this solution. That is, if you look carefully, this Redis sorted set is the single point of failure in this entire design. Means if this thing is down, we are done. Because there is no way we have a backup in our memory, as well as this is responsible to have all the data in the memory. Means it can be billions of videos, songs and whatsoever. We have to keep it in a single Redis instance. So obviously it is a huge pressure for a single Redis instance to store all this data in the memory. And if you look carefully and understand the logic, what we are doing, here we are ingesting all the data in this Redis instance without any time frame. Means all the data that we have from months and months old will get ingested over here. And once the user requests for a data for a 30 or 90 days, then it will be very difficult for us to get it from this Redis sorted set, because this Z set have all-time data in the memory. I hope you got the idea that what is the problem we will be facing with this implementation. So let's see how we can optimize this solution. So here to solve this problem of all-time data, what we can do, we can handle this implementation a bit cleverly. That is, here instead of just keeping a single key in our Redis Z set, we can create multiple keys in the memory. So what this key stands for? So just to give you an idea, what we are doing earlier, this is the way the key was designed or the heap structure was getting designed in this Redis Z set. That is, for example, we have a single leaderboard for the music library and it is for India. And what we were doing, we were saving all the all-time data in the memory. But right now, just to have all the forms of data, means all the time frame of the data, what we can do, here we can have multiple keys in the memory. Means here we will be having one for 90 days, one we can have for the 30 days and so on. So here with this way of implementation, we have solved one of the problem. That is, right now, this Redis sorted set have all the time frame of the data. It have all time data, it have 90 days data, as well as it have 30 days data. So all the form of the data is already present in this Redis sorted set. And thus it can return the response with a very low latency. But there are few problems again with this implementation. That is, here if you look carefully, what we are doing, here we have only created key for the country India. But you can easily understand, if we keep on creating a key for each and every country, the data that we will be saving in this Redis sorted set will be tremendous. So there will be a lot of overhead on this Redis Sorted Set. So this way of solving this problem is not a feasible solution in case the size of your application is quite huge. But believe me, if your application is deployed only in India or only at a particular country, this is a very good solution by which you can find out the top K trending item. Because since here we are using a Redis cache to fetch all the data, so you can easily understand that the latency will be very nominal. And since here we have only a single instance of Redis, it is also will be difficult to scale. But there is a solution to that also. That is what we will do. Instead of just using a single Redis instance, we will use a Redis cluster. And how we will partition it? It will be partitioned based on the country. Means all the data of India will remain on a particular node of the Redis. Similarly, all the data of the US will be there in their Redis. So in this way, we can solve both the problem, that is the time frame problem as well as scaling the Redis sorted set globally across different clusters. I hope this is clear that how we are solving it with the first way of solving this problem. So let me just write this note over here so that it will be easy for you to understand later. So this is how the first way of implementation works. That is, we are using a Redis sorted set to store all the attribute. After that, since Redis is a sorted set, so obviously it will order automatically. So we do not have to write any logic to sort it in the server. And how we are storing the data? We are storing it with the help of the key that will look something like this. That is the leadership board, the country and the time frame over here. I hope this is clear. But what is the advantage of this approach? The advantage is this is super fast and easy to handle, because since all these things are in the single server, the data retrieval time will be very optimal and the latency will be negligible. But there is a problem with this approach, that is the scaling of the system, because the Redis instance should be there in a single node, and by any chance if that node gets destroyed, we have to compute everything from the scratch and it will take a hell lot of time to do it from the scratch. I hope that is clear. And how we can solve that problem? We can solve it by creating the Redis cluster by region. And also we can take the snapshot or the backup in our database so that we do not lose all those pre-computed data. So that if a particular node or the instance gets down for somehow, we can just restart that server or node and thereafter it can get the previous snapshot version from the database. So by this architecture, you can easily solve this problem, but it is only applicable if the scale of your system is minimal. I hope this is clear that how everything is working on the first way of solving this problem. Now let's see what can be the other approach of solving this same problem with a completely other way. So what we will do here, we will go with our second way of designing. So I will again copy this entire designing from here and we will go with our second approach. And here in our second approach, the way we are ingesting the data will remain the same. Means this flow will not change. But here, instead of using the Redis cluster, we will try to do something different, because the main problem with the Redis cluster was to scale across the globe. And to mitigate that problem, what we will do, here we will get rid of this Redis cluster. And here we will see that how with some other approach we can solve this problem. So the other way by which we can solve this problem is with the help of the pre-computed data. So what we were doing over here is like, we were trying to fetch all the data in near real time, because whatever the data is coming into our code service is within our Kafka, it was getting ingested and it was getting persisted within our ZSET. And thus with this approach, we were giving a near real time data. But as you know, there was a problem with this approach, that is the scalability and the durability of the data. So let's see how we can solve this problem. So here in our second approach, what we will do, once the data is there in our code database, we have to run some cron job to pre-compute the data, so that whatever the data this client service is asking for will be already present in our code database, so that we can give it to the client in almost near real time. So let's see how that flow will work. So what will happen once the data is there in our score database? Here we need an additional service, and the service that we will be using over here can be a Splunk or it can be an Apache Flink to compute all the data that are already there in the score DB. So here what we will do, here we will be using the Apache Flink. So here I will introduce a Flink over here, and what this Flink will do, it will simply get the data from the score DB and it will pre-compute all the data that is needed. And all this data which are pre-computed based on the region, time frame and everything will be present in a separate database that is nothing but an aggregated database. So here we will be having one more database called as a aggregated DB. So all the data are there in the score database, and from there Flink will compute all the data, and based on the region, time frame, genre, whatever, it will store all this information in our aggregated database, so that once the ranking service requests for a particular bit of information, it can simply query this aggregated DB to fetch that relevant information. I hope this is clear that how with this flow we are also solving the same problem. But the question is, what should be the database that we will be selecting over here for the aggregated DB as well as score DB, so that we can query the data in almost near real time. So the database that we should choose for the score DB can be anything. It can be a Spanner, it can be a BigQuery, or it can be a Cassandra. So if you look carefully over here, based on the property of the Cassandra, BigQuery or a Spanner, you can easily go with a Cassandra database, because Cassandra is a write optimized database. And as you know, since there will be millions of requests that we have to ingest in our database, so obviously this database should be write optimized. And the best write optimized database should be the Cassandra over here. But you can go with any database that you want. So here this is the database. Now comes the main thing, that is the Flink is processing the data from this database and it is pre-computing everything and it is pushing it in an aggregated DB. Now what should be the structure or what should be the aggregated DB? So here if you look carefully, this ranking service have to frequently query this aggregated DB based on the time frame or based on the region. So what we can do here, the best example or the best database that should be perfect for the aggregated database would be our time series database or our influx DB. So this will be our time series database. So if you want, you can also store it in a Postgres solution, but you can have to do a lot of partitioning and indexing based on the country, region, genre and everything. So here if you look carefully, with the second way of implementation also, we have solved this entire problem. But there is still a small problem, that is here the data that we are getting in our aggregated database is not real time, because there is a lag due to the processing time of the Flink, because the data is first getting ingested in the score database. After that we are computing with the help of a Flink, or it can be a cron job whatsoever, but there will be a small latency in the top K trending item in the backend. So this is also a feasible solution if your system doesn't demand a real-time top K trending item. I hope this is clear that how the second way of implementation solves the same problem. Let me also write all these things so that it will be easy for you to understand in the future. So this is what we were explaining, that is here we will be pre-computing all the data and here all the scores will be saved in our NoSQL or a SQL database. After that we have to pre-compute all the data with the help of the Flink, Airflow, whatever the technology you want. We have to pre-compute the data and you have to put it in the time series database. So this is what everything is written over here. And to optimize this thing even further, what you can do, you can easily introduce a caching layer over here so that our ranking service do not have to hit this aggregated database each and every time. Rather it will just hit our cache layer so that all the pre-computed data will easily be retrieved from the cache. So here you can see with the help of our second approach also we have solved this problem. Now let's see what will be the third solution of this problem and the best solution of all. So if you remember, with our first solution the problem was the durability and the scalability, and with our second solution the problem is the data was not real time. So on our third solution we will try to solve both the problem. And how we will do it? We will actually create a hybrid solution, and we will create a third solution which will take both the solution together and create a resilient solution. So let's see how the architecture of that third approach will look like and how it will solve the problem. So what I will do, I will merge these two images together and I will get back with our final solution which will probably solve both the problem. So let's see how the third solution will look like. So here you can see this is our third solution where we have done nothing. We have just merged the two solutions that we have discussed earlier. Here we have both the Redis set, that is the ZSET, as well as our backup process. But let's see how this will solve all the problems that we were discussing earlier. So here if you look carefully, though we are storing all the data in the Redis Sorted Set, but here we are saving it a bit intelligently. That is, here instead of saving everything that we get from the viewer or from the user, we are putting a TTL on each and every key that we are computing. So for example, you have a data for 90 days. What we are doing, we are just storing the data for only 90 days. And once that 90 days is over, that entry will get deleted from our server. So that here we are not saving all the pre-computed data, rather we are only saving that is necessary. And also what we are doing, here there will be another connection from this Redis Sorted Set to this aggregated database. Means there should be another service by which if this Redis instance goes down, we can simply get the pre-computed data from this aggregated database. And thus with the help of this, we have backup of all the data that we have computed in the Redis cluster, as well as all the pre-computed data is already present in the Redis DB. So what is happening once the user is requesting for a particular data, it is first checking that whether the data is present in the Redis Sorted Set or not. So if the key exists in our Redis Sorted Set, it is well and good. Otherwise, what will happen? It will go into our aggregated database. But keep this thing in mind, whenever there is a miss in the Redis database, it can be only on a particular scenario. That is, you are requesting for a past data, because all the latest data are there in the Redis Sorted Set and all the previous data will be there in the aggregated database. So for example, you want to fetch data from the last January, that data is already pre-computed in the aggregated database. But if you want to see the data of the last 30 days, that will be present in this Redis Sorted Set. Means all the trending current data should be present over here and all the past pre-computed data should be present in our aggregated database. And with this architecture, more or less you have solved both the problem, that is the near real-time update with the help of the Redis Sorted Set, as well as the backup or the durability with the help of this aggregated database. I hope you are clear with how this entire flow is working over here. In case I have missed something, I will just give a note over here so that it will be very easy for you to understand. And as you know, I keep on uploading all these images and the PDF file in my website. So do not forget to check in the link provided in the description. So let me write all these things over here. So here I have wrote down everything. Just feel free to go through all these things if you do not understand on the first go. So here if you look carefully, we have successfully found the solution of all the functional as well as the non-functional requirement that we have gathered. The only small thing that is still missing, or it can come in the follow-up question, that is how we should give a real-time update to the user. And as I was discussing, to give a real-time update to the user in case of a leaderboard, you need a WebSocket connection. And to implement that, what we have to do, here somehow we have to implement a WebSocket server by which we can give all the real-time data to the user or to the client from this Redis Sorted Set. I hope this is clear that how we can also get the real-time data update from our backend in near real time with the help of the WebSocket connection. So I hope you have thoroughly understood this video and you have found this video useful. And if you have found this video useful, do not forget to like, share and subscribe to my channel and hit the bell icon so that you never miss an update from my side and you are always ready for your next interview. So see you on our next video where we will be solving another problem on system designing. See you on our next video. Thank you.